All right, well, hello and welcome to today's webinar, Data Management for Quality Control. I'm Elizabeth Clore from Infinity QS, and I will be moderating the webinar. The presentation portion will last for about 45 to 50 minutes, and then there will be time for questions and answers at the end. If you do have a question during the presentation, please just type it into the chat box, and Steve will answer it at the end. We will be sending you a copy of the slides from today's presentation at some point tomorrow. So now I'd like to hand it over to our presenter, Stephen Voigt. Steve is an application engineer here at Infinity QS, and he joined the company back in 2008. Steve works on site with customers implementing our software and leading the fundamentals training course. So now I will turn it over to Steve.
Thank you, Elizabeth, and good morning, good afternoon, everyone, depending upon what time zone you happen to be in. We have a lot of material to cover today talking about DMS, our data management system, and how it can help you bring data in from various places around your factory, around your enterprise, and bring them into your SPC system to help you improve your quality data. So let's just jump right into it so we can get started. So a little bit about what DMS and DCS are. A DMS, the Data Management System, is a service which manages data from multiple sources around your factory, and that data can come from any number of different places. Could come from databases and could come from text files and a variety of different places we're going to be talking about. But it's a single repository for managing all of those data sources that are coming from outside. And it stages that data for consumption, eventual consumption by the other component, which we'll be talking about, DCS, our data collection service. Now, DMS is considered to be a live data warehouse, meaning it doesn't store data on its own, but it just manages data that's coming from external sources and keeps that data live from various places into a single location so that we can access it for our SPC uses. In addition to pumping data into DCS, you can also have the DMS data go into a historian table that's part of the Proficient database, and we'll talk.
Stephen.
Yes.
Sorry, I kept trying to interrupt you, but you were giving such good information. I can't see your desktop. Are you sharing it?
Oh, sorry. Thanks for interrupting. I guess I really should have shared that. Let me see if I can share that and everyone can actually see what I'm talking about. Oh. How was that? Is that better?
That is much better. Thank you so much.
Oh, sorry about that, everyone. You think you have everything all perfectly in line, and then you forget one little mouse click, and everything goes away. All right, so let's pick it up again. Luckily we just got started, so thank you again, Elizabeth. So just to cover again what I just said about DMS and how it gathers data from various sources around your enterprise and brings them in and makes them accessible to the SPC system. So the other component of that I mentioned is DCS, our data collection service, and excuse me, and that's a complement to DMS in that all the data that's collected by DMS from various places around your factory are gathered together and combined by DCS and compiled into subgroups that are useful to our Proficient database. And what's nice about DCS is it can grab data from many, many different sources that DMS has harvested from and combine them, and we'll see the utility of that as we go further in the presentation. There's a little bit something new that's been added to the most recent version of DCS is now instead of pushing data to the Proficient database, subgroup data to the Proficient database, we can also publish those records now as IDEF files, and that's the Infinity QS Data Exchange format. And if you're familiar at all with our EIS Enterprise Integration Service, you'll know how that can fit in and how that can help you in accumulating your data from various sources. I'm not going to talk about that in detail during this presentation, but if you have questions about that, I'll certainly be happy to answer that at the end of the presentation. Finally, the nice thing about DMS DCS is that allows you to save subgroup data even when Proficient is not running anywhere in your factory. It doesn't require an operator or someone to be collecting data and entering it in. It can happen all by itself. So what are the benefits of DMS and DCS? Well, one, these items run as Windows services, and so just strictly from an IT standpoint, they're a lot easier to manage, a lot less time consuming to configure and set up and to maintain. But some of the big things that it provides are obviously in the areas of SPC. It helps you support what we call lights out SPC. So you can actually collect your quality data automatically with no human interaction whatsoever. It can just gather the data from those external sources and push it to the database. But it also, in addition to doing this lights out sort of automatic data collection, the other benefits is that it just decreases the need for that manual data entry. So if you can grab this data automatically instead of entering it manually, it reduces data entry errors from operators keying in data that they're gathering. They're perhaps wandering around their shop floor writing down values from various displays on various machines and then rekeying that data in. We can grab that data automatically. It reduces the potential for error from data entry. And also reduces the data collection needs for your operators. If they're again wandering around your factory floor with little pieces of paper scratching down values from various HMI displays or various readouts around the floor, if we can grab that data automatically, we don't need to have the operators doing that. So it reduces the loading on the operators. Another benefit that provides is that it can help you focus on your inputs to your process rather than focusing primarily on your outputs. And outputs are just what sort of naturally occurs when you do manual data collection. You're reading weights and things of that nature, and things that have already been produced. DMS, by being able to grab data from machines, for example, various temperatures, pressures, flows, whatever it might be, can help provide data on the actual inputs to your process rather than focusing primarily on your outputs. And I think you can see that focusing on that, having some input data can help you drastically as far as solving problems and improving your overall quality. So let's talk a little bit more in a graphical sense about how DMS works. Pictures paint a little bit better picture than just talking about it or viewing words on the screen. So let's assume that you've got on your factory at your site, you've got various sources of data. You may have an MES system that keeps track of various items. It could be a historian database that some of your automated systems are automatically feeding their data into. You could have a production scheduling database, a database in your factory that's aware of what products are running on what line and what lot codes are running and what date codes should be used. You could have an OPC server, which is grabbing data from your various PLCs on all of your processing equipment. Could be grabbing temperatures, pressures, flow rates, a lot of those different things that the machines are able to provide. And it could be, you also have a visual system, some sort of measurement system, a CMM, some sort of test stand that's generating data, even gauges or things like that that are electronically generating data. And these exist around your factory floor. And they have, if you take them all together, they have all of the information that InfinityQS needs to do a good job of creating subgroups and giving you valuable data. It has what part you're running, what shift you happen to be on, what lot. All of that sort of information exists in various repositories around your factory, but they're not all in one place. So, and these things are being constantly updated and being refreshed, and there's constantly new values being updated. But the problem is, if we were to try to connect to any one of those individually, it just wouldn't be enough. There's not enough data in any one of these places to provide enough information to make adequate subgroups to be fed into our database. And that could be the same with a variety of the data sources. So you've got all this information there. You know it's useful, but each individual individual source is not as useful as it could be. So what DMS does is it acts as a repository for that data coming from various sources, and it's called what's called our live data warehouse. And it enables you, DMS can have tap into those variety of those data sources and maintain all that live data that your various systems are generating and storing, and put them in one place. So finally, what you have is then a single place where all of that necessary information exists all at the same time. And so it enables you to put all those together, and DCS then can combine the data from the various sources and then push those subgroups into the Perficient database for you to monitor and analyze and alarm on your various systems. So that's how it brings it all together. So let's talk a little bit more about DMS in particular. DMS is the component, as we mentioned, that grabs data from various external sources. And there are a lot of different what we call providers that come with DMS. And each of those is meant to tap into a different sort of external data. There's a few that we're going to talk about in a little more detail, but there's a variety of different ones for tapping into different databases, different sorts of text files, all different sorts of applications. So we'll talk a little bit more about those, a few of the more popular ones of those as we go on. Now, on the other end are the consumers, which will use the data that DMS gathers in its live data warehouse. And the one we're going to talk about mostly is DCS, which is the one that grabs the information from DMS, combines it into viable subgroups, and then pushes that data into the Perficient database. We also have the historian table, which will take data directly from DMS, and we'll talk a little bit more about that as we go ahead. Okay, so one of the there's several providers I'm going to talk about right now, but one of the ones that's used very popularly is what's called our grid provider, and I'm going to talk about that one first because that's the one I'm actually going to use in the demo as we move on to the demo portion. The grid provider is made to tap into various sorts of file-based data. So if you have test stands that generate text files like a CMM or some other type of test stand, that generates text files. If you have gauges that communicate over RS-232, or even gauges that excuse me, that communicate over the internet over a TCP/IP, you can interface with these files, with these data streams, and you can see here we've got, as part of the setup, you can see the various types of files various types of sources of data that the grid provider can use. And you just basically specify where that data file is located. Let me go back here for a second. You specify where that data is located. And in this case, it's a file. So you can just see here in this example, I've just got there's a path here that's set. And once you have that data brought in, we need to parse that data and split it up into usable chunks. So it may be a multi-field, a multi-column spreadsheet. Well, we need to know which column belongs to which sort of data item that Perficient needs. If it's a part or a process or a data value, and so there's a way to parse that data out into the various components that we need. Finally, once it has the data and parses it in, we need to talk about how often these records are going to be presented to the live data warehouse. As mentioned, DMS doesn't store data, but it only uses what's called live data. So if you have a spreadsheet, for example, that may contain 10, 20, 100 different records, DMS is going to publish those records to the live data warehouse one record at a time, and you need to let DMS know how long, for what period of time each of those records is going to remain live. So that's where that's done here in this flow control section. Another provider that's very commonly used is our OLEDB provider, which is used for tapping into any variety of database. Any database that communicates with SQL query language can be queried by the OLEDB provider, and data can be brought in. So where could this be? This may be a production database that knows where what's being produced on a given line at a given time. It may be any sort of different things. Some other type of historian database. So this lets you establish a connection to a database, and then using standard SQL language, you can compose queries into that database. And we also allow you there's two different types of queries. There's a startup query, which you see down here at the bottom, and that's used to establish what are called tokens in your query. And the processing query then can use that token, and what that does is every time you query your database, because you're going to be doing it on a regular basis, it helps prevent you from requerying the same data again and again and again. It kind of keeps track of what data you've already queried, and so it doesn't bother returning that in future queries. So again, then you need to tell it how often you want the database to be queried, how often you want to execute that processing query. And then finally, the results of that query may be a number of different records, and you need to tell DMS, again, how often you want those records refreshed, how long each of those records will remain live in the live data warehouse. Another provider that's also commonly used, actually there's several providers that are fairly similar in this regard, is ones that are meant to tie into tag-based database systems. And these could be like an OPC server or Wonderware or the GE iHistorian. These are special kinds of proprietary databases that have their own requirements, and this allows you to connect into those databases. And then also allows you to look at all the various tags that are published in that database, and then you can pick and choose what tags you want to bring into DMS. It's basically a different way of querying a database, but a more precise way tailored to that particular kind of database. And the final thing with this, I'm showing the OPC provider here as this generic sort of case. You also can set sampling requirements for how often, just as with the OLEDB provider, you can set sampling requirements for how often you want to sample data that's coming from that OPC server. As you're maybe aware, PLCs and OPC servers can refresh data at a very, very high rates in the sub-second type of range, and that probably won't be useful in an SPC sense, so you can set up how often you want to sample that data stream. There are a couple other providers we'll talk about a little bit, just to give you an overall flavor. The data converter provider is what you can use to actually perform some comparisons and some modifications on existing DMS items. You may have a DMS item that brings in data from multiple lines, but you want to separate that into individual streams, and there's ways to do that. And that's actually part of the demo, and I'll show you that a little bit more detail as we go forward. The remote bridge provider is one of our newest ones, and that helps with some issues. If you've got issues between where your DMS instance resides on that whatever particular server that is and where your source data that you're seeking to capture is coming from, a lot of times there's security issues, permissions issues, communications issues that can become hindrances to that connection. So this allows you to have a separate instance of DMS more local to your data source, so it can harvest the data in a more direct fashion. And then the bridge provider allows those DMS instances to talk to each other and then pass that information on to your main DMS instance. It's just a way of getting around some of the security issues and permissions issues that we've come across. So finally, when you have your DMS tags configured and running and capturing data, there's an activity window that will display all the tags, and it will display the real-time values that are being captured. And there are several ways to view that data. You can either view it just as tabular data. You can view it as bar charts that update whenever a value is updated, or line charts. Just some other ways to kind of look at the data as it's coming into DMS to get a better feel for how the data is looking. So the DMS historian, you can choose, instead of having the data consumed by DCS, which we'll talk about in a minute, DMS can just push that data directly into the Proficient Historian table. And that can be consumed not automatically by pushing it into the database, but by a Proficient project. So the data that comes in through DMS becomes accessible through a regular Proficient project that you might have out on the factory floor. So why would something like that be useful? Well, I'll just give a couple of examples. One is, say you've got a tool, for example, a scale or some kind of measurement system that's shared by multiple lines and multiple workstations. You can use DMS to push those readings into the historian table rather than into a specific project. And then the project at each workstation can then actually just query that historian table for the readings that belong to that line, and then choose those as their data inputs for that project that's located on a different line. Another very useful use of the historian table is for adding live machine data to manually recorded subgroups. So, for example, so DMS, as we've talked about, can grab live data like from PLCs or things like that. And so it can be very useful. So if you've got an operator on the floor collecting weights for something, for some fried food, wouldn't it be nice to be able to say, by the way, can you also go grab me what the current fryer temperature is when this weight was recorded? And that can happen just basically automatically. And it's a nice way to add extra depth to the subgroup data that you're collecting. Add some of those inputs along with the outputs, and it can be very helpful as far as correlating and analyzing your data as time goes on. And those are a couple of good uses for the historian. So on the other end, after DMS has collected all the data and put it into the live data warehouse, we need to get it into the Proficient database, and that's where DCS comes in. And DCS is used to combine data from any number of different DMS providers and form them into Proficient subgroups. So when configuring DCS, the first thing you talk about is your sampling. As you know, we're an SPC company, and we are all about sampling. So you can decide how often you want to sample the data stream. You may have data coming into DMS on a fairly rapid basis, refreshing very very quickly, but you may not want all those values fed into your Proficient database. So you can decide, hey, I only want to sample that DMS data stream every number of seconds, minutes, whatever it might be. So then once you set up your sampling, you can do other things like synchronize when DCS actually executes the subgroup collection. That can help, like if you have a number of different DCS configurations, can help balance the loading on the database so you don't hit everything all at once and you kind of spread things out. The other things you do when you're configuring DCS is obviously to define where you're getting all your various information that you need for part, process, and test, and your data values and your descriptors. And so you go through and pick and choose how you're going to set those up. So you could use DMS items for those values. Like in this example, we're using, to grab a temperature, we're using a DMS item right here, and this is just it's a little cryptic representation of a DMS tag, but we're just grabbing a temperature value that's being brought in through DMS. You can use fixed values. For example, if this PLC is always generating temperatures for oven 1, then I know always to assign. I can just assign it to oven 1 automatically. I don't have to go find that somewhere. I can just fix it. Also, if there's information that's just simply not available through DMS, if there's a lot code that you just don't have available for automatic collection, and it's something the operator needs to enter, we can configure that so that the operator can just make a selection in a conventional Proficient project, and DCS can grab that value and combine that with the other DMS values and make it into a subgroup. And lastly, DCS can also perform some arithmetic calculations on the fly. So if you want to take a difference between a couple of temperatures, you can do that very easily. If you want to convert from Fahrenheit to Celsius or from ounces to grams, you can do those right in DCS and perform those conversions on the fly. It's a very powerful, a very convenient feature. So here's where if you were going to select a tag for a particular item for DCS, you would just click on the selection button, and it would bring up a list of the tags that are available, and you would just pick and choose whatever one you wanted to use for that particular item. Lastly, the last part of a DCS configuration is to set up what are known as conditions. Now, since DCS is meant to happen, automatically, it's supposed to collect data regardless of whether anyone's paying attention to it or not. We have to build some intelligence into it so DCS can discern what's a real subgroup and what's a valuable subgroup and what isn't. So here's where you can build in some conditions for data collection. So for example, if you have a PLC tag that is 1 if the oven is on and 0 if the oven is off, you can use that and say, only collect my oven temperature if that tag value is a 1. Or only collect the value if the timestamp for my DMS is new, meaning that the data has actually been refreshed. So there are lots of very powerful things you can do to build some intelligence into DCS so we can discern between usable and non-usable subgroups. And you can see here there's a variety of different types of conditions you can use. One are just global, which meaning the DCS won't execute unless this condition is met, but you have various conditions that might distinguish what the start of a subgroup is or what the end of a subgroup is in various items. And there's comparative values you can use in these conditions. If you can say if this value equals this other value or doesn't equal, and there's all sorts of comparative tags you can use. So what's the net result of all this DMS and DCS? Well, you may have data in a lot of different sources and a lot of different places around your factory floor, and you want to bring those into your SPC system for analysis and monitoring. So you may have OPC servers grabbing your PLC data from your various processing equipment. You can bring those in with OPC provider. You may have other pieces of equipment, a checkweigher or some other kind of test stand, a CMM that's generating flat text files. You can hook into those and pull those in. You may have external databases that are grabbing historical data from around your floor, or it may contain structural information like lot codes and what part is running on what line. You can grab that data and pull it in. You may have gauges all around your factory floor, and we can hook into those as well. All of this data can be, through various providers, can be brought into one live data warehouse and used to create subgroup values for your Proficient database. And this can happen all simultaneously, fully automated collection from virtually any data source. And this can enable, among other things, lights out SPC, where you can grab your quality data without any human intervention at all. So now that we've talked all that good stuff about what DMS and DCS can do, let's go through an example. So I've got my example today is a chicken processing company. And they manufacture 1 ounce and 2 ounce chicken nuggets. And they have 2 production lines, 2 frying lines, where they fry these chicken nuggets. And on fry line 1, they're making their 1 ounce chicken nuggets today. And on fry line 2, they're making their 2 ounce chicken nuggets. So also on these 2 lines, they've got one operator. They're a very lean operation, as a lot of operations are these days. They've got one operator that's working both of these lines. Now each line has a dedicated checkweigher at the end of the line, and as these chicken nuggets are fried and come out, excuse me, they're weighed going across this checkweigher. Now both lines share a single scale. There's one operator, so they just have one scale at line. So regardless of whether it's a 1 ounce or a 2 ounce chicken nugget, they're going to be weighed on this same scale. And also they have an ERP system local in this facility that has the scheduling information with what products are running on what lines and what lot codes and date codes are available. So that's available as well. So here's a graphical representation of what I just told you. We have an ERP system that has the following information. It'll provide what part is running on what line and what lot code is to be used and what the date code is. So that's available in the ERP system. And we've got the two fry lines there with a scale that the operator uses to measure nuggets from both lines at the beginning of the line, and then each line has a dedicated check weigher at the end. So what do we want to do? Obviously, we want to make data collection simple for the operator. There's one operator on two lines. He or she is a very busy person. We want to track not only the individual weights, but we want to track the weight change from the beginning of the line using the scale to the end of the line at the check weigher. So we want to get an idea for how much our nuggets are changing in weight because of the frying process. And we have to do all this using a single scale at the beginning of the line. So we have to find some way to keep line 1 data separate from line 2 data. And we need to automatically calculate the difference between the scale weight and the check weigher weight for each of those lines. Okay, so that sounds like a pretty daunting task. So let's see. Okay, so one last thing. So we need to provide the operator with information so they can manage both lines, so they can manage the differences in weights between the scale and the check weigher, so they can keep track of those things and see how their data is performing. We need to make it fast, and we need to make it easy. So now comes to our demo portion. So I'm going to hop out of PowerPoint here, and I'm going to bring up DMS, and I have DCS here. And so what we've got going here. So here's my DMS window. And you can see I've got a number of different configurations set up here. Now, I don't have an ERP database from where I'm doing this presentation. So I'm going to be using text files basically for all of that information. So I'm using, if you can see here, I've got mostly what you see are grid data providers. So this is mostly text files that I'm using, but it could just as easily be a database or a gauge or something like that. Okay, so you can see I've got a configuration for each of my lines for the schedule. So this is where I'm going to be grabbing my part, my process, my lot codes, and my date codes. I've got two configurations, one for each check weigher. I've got one configuration that's for grabbing my scale data, which could belong to either line. And then using these data converter providers, which I'll talk about, I'm separating this scale readings into and differentiating between what belongs to line 1 and what belongs to line 2. Okay, so let's just show you quickly what my text files look like. They're pretty simple. My line 1 scheduling, here it is. It's just one line with 4 fields in it. Here's my process, here's my part, here's my lot code, and here's my date code. And that's just basically one value. And that's going to represent what my query would be to my production database, my scheduling database. And that's going to be the result of that. And the same thing with line 2 is the same thing, just a different information. My check weigher data sources, again, I'm using a text file here. It's just a number of values, and that's basically all it is. There's no part information, no line information, no nothing. It's just a series of numbers, and that's all it is for line 2 as well. So how can I take that and make it into something useful? Okay, so let's have a look at my scheduling. One of my scheduling configurations. So I'm going to edit this and open this up. And you can see, so here's my grid provider settings. So here's my connection. Basically, it's just I've just chosen a file path. I want you to look in this folder for a file of this name. And you just do that using normal Windows Explorer selections. And here's where I select my format. And as I mentioned earlier, the format is, what do I do with this data? I've got this data that has various fields in it. Well, I need to know what each of those fields mean, what each of those fields are for. So here you can see I've got it set up so that my part is in column 2, my lot code is in column 3, and my date code is in column 4. There's a bunch of other stuff here I'm not going to bother going into, but this is just how you handle like what the different, how can I tell what separates my columns and what determines in the end of a record. So here's where I've got my data parsed. And finally, there's a flow control here for how often I want those records to be updated. But I've only got one record here, so that really doesn't come into play. It'll come into play in a second when I look at the checkwares. Okay, so what I'm going to do is you can see in my DMS window, these are currently disabled. So what I'm going to do is I'm going to enable both of these. So I'm just going to right click and say enable. Okay, so now these are both basically waiting for data. They are looking in that file, that folder location that I specified for a given file name, and they're just going to sit there and wait until a file shows up. So here's my source, my data source files that we talked about, and here's the folder that it's looking at. It's expecting to see those files existing in this folder. So all I'm going to do basically is grab this line 1 schedule and just move it into there. Okay, so you can see what happened is it saw that the file was there and it said, oh, I'm grabbing this, and you can see that the light turned to green, and if I double click on this to show the activity, you can see that right there are my values that it just grabbed from that text file. Now, DMS will hold this as live data until that query to the database is the query to the scheduling database is done again, and it'll just keep this value here. So this value is just going to stay here and be usable for any data that's collected until it gets updated. So I'm going to do the same thing with line 2. I'm going to drag it to that folder, and now my line 2 schedule information is there. So now I have my part, my part for a given process, and my lot code and my date code, and they're just there available.
Just so you understand, we gave Puerto Rico $91 billion.
Now let's move on to the next
That's
phase
the largest
of this, and let's
amount
start
of money
collecting
ever
data
given to any state.
from our
Talking about
checkwares.
states in Puerto Rico.
These are set up very similarly to
billion
the scheduler
Texas
configurations.
got 30.
Again, I'm looking in a certain folder
Florida
location for a
got
file.
12. Puerto Rico
this one, the
got $91
format's
billion.
even simpler.
So I think the people of Puerto Rico should
I'm just
really
looking at
like
that one field and grabbing
President
that
Trump.
and calling it my net weight.
Congressional correspondent Phil Mattingly
Now,
here
the
with
flow
me
control is
now.
a little bit different here because if you remember that file had a whole bunch of records
That's the fact check.
And what I'm
let's just start from
saying
the
is
top
that
line. That's not true.
For
What
all
the
those
president
records in
said
there, I want
today
each
and
of
what he
those
said
records
last
to be
night on the
held
Panhandle in
for
Florida, where this is
2,000
obviously a big
milliseconds or
issue,
2
what he
seconds.
said repeatedly,
So basically,
including in
this
closed
is
door lunches and
saying
closed door
that my
meetings with Senate
checkware is
Republicans,
reading 1 chicken
the
nugget
$91
every 2
billion
seconds.
number.
Okay, so I'm going to enable both of those. Turn those guys on, and now I'm going to grab my checkware files and drag them to that file folder so it starts harvesting those values. Okay, you can see that those lights are turning green and are starting to update values. So you can see that the values are updating here. If you want, I can turn on the Okay, so I got that. So I've got those are both running. Okay, so I've got my checkware values coming in. I've got my part, my lot code, my date code. So now that we've got some subgroup data that we can collect, let's switch over to, I can put this away. Let's switch over to our DCS. So you can see I've also got a number of configurations here. I've got my 2 checkware configurations, and then I've got the scale ones, which I'm not going to talk about yet. We haven't gotten that far. So let's look at my checkware configuration. Okay, I've just got this here. I've got my sampling. What I've decided, if you remember, I've got checkware values being captured, being published by DMS every 2 seconds. But I've decided that that's too often. I don't need to actually collect data into my SPC database that fast. So I'm setting my subgroup time at 6 seconds. So DCS is only every 6 seconds going to go and go grab data from DMS and form a subgroup. Now, I will say that I made it 6 seconds just for the purpose of this demonstration, so you could watch the data update in a reasonable fashion. 6 seconds is probably still too fast for grabbing this data for live SPC purposes, but just for the sake of demonstration, I've got it set at 6 seconds. So my descriptors, so here's all the different things that I need for a subgroup. I've got part, process, I've got my lot, and I've got my date code. And you can see that my part, I'm using a DMS tag, which is basically from my scheduler configuration. So I'm going to double click on there and just show you how that works. So I've got this item here, and if I wanted to pick it, I just click on this button, and it brings up about all my DMS tags. There's a bunch here. You can see all the ones that are updating. And I just select that DMS tag, and that's going to serve as my part. My process, well, I've already decided that all this data that in this configuration is tied to only line 1. So I can just fix that. I don't need to query anything for that. I'm just going to say, you know what, any data that comes in for this is going to be tied to fry line 1. So I can just leave that alone. My lot code and my date code are brought in the same way from that scheduler DMS configuration. So I've got my part, my lot, my date code, my process, and the last thing I need is my actual value. And you can see I'm just grabbing, it's just another DMS tag that I'm grabbing. This one is from my check weigher and my net weight. I've got a couple of conditions here that I've set up. The first one is I want to make sure that the data, the value from my check weigher is actually a newly published value. So in other words, if the check weigher if the line was stopped and the last value was still live on the check weigher, I don't want my database my SPC database to keep bringing in that same value over and over again. So I'm going to say, hey, I want that timestamp to be new. I want to make sure that that value is actually a new value, not an existing one that's just been queried again and again. The other one is that just for a kind of a filter, I'm saying that if my value has to be greater than half 0.5. Now the spec on this one happens to be 1. So it's basically saying that if there's a value that's like 0.25, that probably just means there's an error or something like that. So it's just sort of a pre-filter for data. Okay, so I've got all those properties going on in that configuration. And so what I'm going to do now is I'm going to turn that one on and enable it. Okay, and we're going to wait. I'm going to turn my other one on as well, which is barely the same thing, just turn to line 2. And you can see that it's now happily capturing subgroups, and it's grabbing new subgroups, and you can see the values that it's grabbing as it's grabbing those things from DMS. And now finally, if we want to go and switch over and look at our our project, which is what the operator would see on the floor, you can see that these values are being brought in on a live basis as they are added in. The project gets updated, and the new values are just showing up. So we're grabbing our check weigher data, and I realize I'm starting to run a little short on time here, so I'm going to work through the rest of these. Okay, the other part of this is where I'm bringing in the values from the scale. So this is using a grid provider, but in this case I'm using a COM port for serial data, and what I've got here is not really a scale. I've got some calipers that are hooked up to my computer, but it serves the same purpose. So let's enable this guy quickly. And what I'm going to basically do is just hit some values on my caliper and just show you that it's the little green flashing light shows you that the values are updating. And just to show you I'm just hitting the send button on my calipers, and you can just see that those values are coming in. Now, I needed to tell the difference between scale 1 and scale 2 readings, so that's where my data converter provider comes in. So let's have a look at this and what this is doing here. Basically, what the data converter provider is doing is saying, hey, look at this scale look at this this line 1, 2 scale value, and if the value is less than 1.5, treat it as line 1 data. So we're using the actual value that's read in on the scale to help it differentiate between what's coming from line 1 and what's coming from line 2. And that's how these two data converter providers work. The other one works basically the same way. It's just looking for the other side of that weight threshold. So I'm going to enable this one and enable this one as well. So we're going to be all up and running. So what I'm going to do now is I'm going to enter a value around 1 in my scale, and you should see this line 1 scale readings turn green. And there it is. So I'm going to do another one there, just show you really quickly. You can see that I'm entering some more values, and it's deciding that those belong to line 1. Line 2 now, what I'm going to do is enter some values around the value of 2, which is my other, what's running on line 2, and it should update this line 2. So now I have them separated so I can pull those out independently, both coming from one scale, but now being treated according to which line they belong to. So the final things as far as DCS goes is I need to bring in the scale data, but I also need to do that calculation and compare the scale data with the checkware data. So how do I do that? So I've got some sampling is a little bit different here. Since I want to bring in every scale reading that I do, I'm just triggering DCS right off that scale reading itself. I'm not doing it at a fixed collection time. I'm saying, hey, whenever I enter a scale value, I want you to go grab it. So the descriptors are set up exactly the same as the others. I'm grabbing the part, lot code, and date code from the scheduling configuration in DMS. Now I've got a couple of values here for my characteristics. One is just my scale value, which this gets a little bit wide here, so I'm going to widen this out just a second. Move this a little bit just so you can see it because they're a little bit lengthy. Okay, so you can see my scale value is just a DMS tag. It's just bringing that line 1 scale reading, which differentiates between line 1 and line 2, and grabs that reading. The last one is some on-the-fly math that we're doing to see the delta. So what we're doing here is taking whatever the current value for the checkware is for line 1 and subtracting from that the current scale reading from line 1, and that's where we're getting our delta value. Okay, so I'm going to turn both of these on, and we will be fully up and running. Okay, so now as I enter values, I'm going to enter values of around 1 that belong to line 1. You can see I'm entering those, and the data is coming in, and also that delta value is being calculated on the fly. So I'm getting real-time change measurements between my checkware and my fryer and my scale. And do the same thing, a couple for line 2. Enter some values for line 2. A couple more. And you see those values there, and my deviations, my deltas are also being calculated. So basically I have an operator who, what they're basically doing is standing at their line, putting samples from both lines on one scale, hitting the print button to send that data into DMS. DMS is determining whether it's a line 1 or line 2 value. It's grabbing data constantly from the checkware. It's comparing those values, and it's feeding all that information into the Perficient database for evaluation, monitoring, alarming. You can see here I'm generating, I'm generating violations that occur on the fly. So all of that information is being captured, and alarms can be being generated, being sent out to various places, emails could be being sent out, and everybody being notified in real time. And basically all the operator's doing is standing at a scale and weighing samples, and that's basically all they're doing to accomplish all of this. Okay, so that's my demo. I hope that was illustrative and useful for you. I know it was a little busy, so I hope you were able to follow it okay and what we're trying to accomplish. You see, there's a lot of things that you can accomplish quite easily with DMS and DCS, and it can really simplify, not only strengthen what you're collecting, but also simplify what the operator needs to do to make that data happen. Okay, so I thank you very much for your attention. If you have any questions now, I will be happy to entertain those.
Yeah, so if you have a question, just go ahead and type it into the chat box, and I will ask Steve. So while we're waiting for people to type in their questions, I just wanted to take a moment to let you guys know about Infusion, our user conference, if you aren't already aware. Many of you probably received an email earlier today about this. Our registration, our special early bird registration, is actually ending on July 31st. So the best time to register would be this month as soon as you can, because there's a significant savings there between the early bird price and the regular price. So our 5th annual user conference, this year it's going to be in San Francisco, California, October 16th through 19th. I encourage you to go to the website, check out the agenda. We have Dr. Douglas Montgomery as our keynote this year. I think he's going to be fantastic. We have Stephen Voigt, who you just heard, giving more presentations similar to this. All of our other experts, Doug Fair, Steve Wise, they'll be presenting as well on topics about our software, SPC in general, best practices, and all that wonderful stuff. Okay, so questions. Does anyone have any questions? I'm not seeing any. We'll wait just a little bit longer. Okay, we have a question from Abby. Could the line 1 and line 2 scheduler information be in the same source, for example, in the SQL database?
Oh, absolutely, they could be in the same source. It depends upon how the SQL database is configured itself, and that may determine whether whether you'd be able to do that with a single DMS configuration, or most likely what you would have to do is have a separate DMS configuration for each line, just to make sure that you keep a live value of what's currently running on each line active at all times. But yes, absolutely you could.
We have another question. What version of Infinity QS do I need to be running to use DMS?
Oh, that is a good question, and I'm not exactly sure.
Wouldn't it be version 4?
I believe it's version 4. I thought at times we were running some version of DMS prior to that. I don't know if there's one of the developers that are on this call. If maybe they could.
It is. I do believe it's version 4, as a matter of fact. Yeah, because we've discussed that, and version 4 is definitely the way to go. There are so many wonderful things you can do with it, such as the DMS, that you can't do on the prior versions.
Right. I know DMS was around prior to version 4, but I believe the most recent version does require version 4.
Yeah, absolutely. Are there any other questions? Okay, well, I'm not seeing any other questions. If you do have any questions, I will be sending you the slides at some point tomorrow, so feel free to just reply back to me, and I'll forward those questions along to Stephen Voigt. And, of course, if you have technical questions, you're always welcome to call our tech support. So thank you, everyone, for your time, and I hope to see you in October at Infusion.